Okay, so here's something else I've been working on because I'm assuming that some of these coils are just not going to ever work as well as when they were brand new. So there's a couple of options. There's one is to buy a new coil, which is around $250 from Bob's Space Racer, BSR. Also, I might consider needing to buy a replacement mole head assembly, which are about $80. But that adds up a lot when you have a machine that almost costs you nothing to buy, and then you would have to spend $250 per coil, and there's 5 coils. So it's quite a big investment. And I feel like the design is not very good to begin with. I mean, yeah, it ran in a game room and it lasted a lot of coins. I don't know how many times these things were replaced, but you know, coming from the pinball world, a lot of coils are designed. Okay. Coils are designed normally to be serviced with a nylon sleeve in the middle, and the coils are also not made out of metal, they're made out of plastic. Seems to reduce the amount of friction since you have a piece of steel down the middle. So I was thinking using 3D printing. I've designed this spool, and I've 3D printed this one, and this spool fits down in the original coil assembly. It actually locates itself tighter than the steel bodied ones. And the next thing to do is to work on winding the copper windings around it to get the right magnetic strength, and also the material selection. So this is PLA, it's not high temp, so it might melt. So I'm trying to actually print this out of nylon so that the heat from the coils won't damage the thermoplastic. So if I get that working, I'll add it to the video. Now I'm going to show the process that I use to wind the coil. So I've taken the 3D printed plastic spool and I've chucked it in my lathe. I set up a spool of magnet wire on a holder, and I'm guiding the wire by hand. So in this process, I'm speeding this up 10 times to save time. I'm going to make 16 layers of the magnet wire, and I found that after 16 layers, when I weigh it, it weighs the same as the original coils. And later on, I test the continuity on my bench, and it also matches the resistance of the original coils. So go ahead and watch this, and at the end I'll explain the results. Here you see the finished coils weighing in at 536 grams. That's 16 layers and it measures 9.25 ohms. Okay, I've been busy and about a week has passed since I last shot a video about Whac-A-Mole, but I've finished my 3D coil, 3D printed coil, and I've wound it and I've installed it and I've tested it a little bit and it looks to be working really well. So I'm going to give a demo of the game and just let you see. This one, the back right, has the 3D printed coil. This is the fastest coil I got. This one is the slowest now. This one's kind of slow. These aren't bolted down here, so they'll kind of pop up and rattle a little bit. This one's bolted in and tight right now. Here we go.
Let's play Whac-A-Mole.
So
do it even faster next time.
There you go. It looks like this coil that I've designed, I've 3D printed it out of a black nylon plastic, so it's high temperature resistant. I've wound it with 22 gauge magnet wire and I've installed it and it looks to be working really well. I've played a couple of rounds with the hammer and I've whacked it and beat it just to make sure it's not going to break too easily. I don't think it will, because after all, it does have this cap that prevents the sideways motion, and the shaft goes all the way through and out the bottom plate, which is also going to prevent like any twisting motion. And so really the solenoid spool is in between these large top and bottom plates, and it really isn't going to have like a lot of sideways forces on it, but still, like the nylon that you can get through a 3D printer is pretty robust. So let me take you around the back and I'll just show you what it looks like. And you can see here's the coil that I designed, and it doesn't have any outer case. It doesn't really need an outer case. It still fits in here a little bit loose, but I created the bottom diameter to be larger than the steel so that it doesn't have as much slop, and I made the top so that it's also a tighter fit, so it doesn't have as much movement up there as well. So overall, it's a pretty simple piece to manufacture because you just 3D print the spool. I threw this on a lathe and I just wound it. Just guesstimated like how much copper it would need, and it's working pretty good. Okay, so to summarize what I've done and what I've discovered with the machine on these electronic solenoid coil based Whac-A-Moles is that this is the original coil that ships in the machine. It's got a brass sleeve inside that doesn't appear to be removable. Over time, it gets worn and damaged. It accumulates aluminum on it, like the aluminum galls to the brass, and it slows the gameplay down to where the moles will get stuck and they just can't even come up at all. These cost around $250 to $350 if you buy them for replacements. I showed in the video earlier some techniques that you can use to clean them. Cleaning them can recover them somewhat, but some of them appear to be just too far gone or too worn out, and so I wasn't able to get them to perform to my satisfaction. So then I designed a 3D printed prototype replacement coil that looks like this, and this would then be wrapped with your magnet wire. So here's the finished version that I've made in my garage. This is actually printed out of black nylon, and then this is 22 gauge magnet wire. So this goes down in here. You still put the cap on to hold it down, of course, because this also keeps the shaft from putting any side load on this. And then you saw in my last clip that it works. So I'm pretty satisfied with that solution, and I'll put a link to my 3D model. So if you want to print it and try it yourself, then you'll be able to find that and give it a try. So thanks for watching.
Let's play Whac-A-Mole.